Okay, well this is a demonstration on dry ice, and here we have some dry ice. You can see it's in pellet form. This dry ice, it's called dry ice because it's actually solid carbon dioxide. The freezing point for carbon dioxide is about minus 78.6 degrees Celsius. So it's about as cold as it gets on a really cold day in Antarctica. So we don't get much colder than dry ice. The reason why it's called dry ice though, is that it does something called sublimation. That is, it goes directly from the solid state to the gas state without passing through the liquid state. Because as you know, at our current room temperature, carbon dioxide wants to be in the gas form. And so the moment that it gets exposed to enough heat, just from our room temperature here, it goes directly from being in the solid form to the gas form. So I'm going to show a few things which is quite interesting to do with this dry ice. Now we can't see the carbon dioxide coming off it very easily, so I'm going to put it into this measuring cylinder of water and you'll immediately see it start to bubble. So you can see this furious bubbling happening there. And of course we've got this amazing cloud coming off the top. And it really is a cloud because carbon dioxide is actually not this white froth. What this white froth is actually a cloud. We've got water vapour being put up into the air above the water that's bubbling here. And that water vapour is a gas, but then it meets the really cold carbon dioxide, which has just come straight from being frozen, and it's enough to basically make that gas, water vapor gas, condense into little droplets, making basically a cloud. And you can see there's a lot of carbon dioxide in there as well, so it's actually sinking down. That's the carbon dioxide is causing it to sink down, and it's taking the water vapor with it. So that's our first demonstration. Our second demonstration is I'm going to take a little balloon here and I'm going to I'm going to put a few little pellets of dry ice in it. Now you'll notice that this dry ice I'm not holding on to it very much. That's because it actually is able to give you freeze burns. So you can see here's our balloon, and I'm going to put it down here and you'll be able to see it grow bit by bit. Now the next thing I'm going to do is I'm going to put some of this dry ice in this little beaker here, and that's just going to fill it up for a while. And we'll see what happens as carbon dioxide goes from being in the solid form to being in gas. And carbon dioxide is actually heavier than air, so it's actually going to stay contained in here. You won't be able to see it, but we will be able to pour it out and get it to do a job for us. But next fun thing, I'm going to put a bit of water into this bottle, and I'm just going to put a very small amount, that's all what I've got left, a very small amount of dry ice into this container here. And I'm going to put a balloon on it, and we'll see what sort of gas it's giving off. So you can see here we've got a lot of this cloud being made there. You can see the carbon dioxide bubbling furiously. And you can see this balloon is rapidly inflating. You can see the carbon dioxide pellets are actually getting smaller as we go. You can see, meanwhile, this balloon is getting smaller. You also see it's actually, perhaps you can see, it's getting water is condensing on it because the balloon is quite cold. So the water vapor, the water gas that's in the air hits this cold balloon, and the particles that are buzzing around in the gas form hit it, the energy gets sapped and they get stuck there. And then another one gets stuck there, and before you know it, we have a little bit of water. That's condensation forming on the outside here. Also notice what's happening here on my little conical flask here. You can see that there is now also some condensation there. We leave it much longer and we're going to find that condensation is going to in fact freeze. So as our balloon is expanding over here, and you can see with our dry ice pellets are getting smaller and smaller over here. this balloon's getting bigger and bigger. Here I'm going to show you a cute little trick. Here I have a candle. Maybe I'll just hold it here. Got our candle here. Dry ice has been in here. I'm going to tip it up and pour the gas carbon dioxide out of my flask. Oops, that wasn't meant to happen. There you go. The liquid, the carbon dioxide gas poured out of the flask onto the flame and extinguished it. In case you didn't see that the first time, let's try it again. Just lighting our candle. The balloon's getting big, isn't it? So here we go, I'm going to put my finger over the top. No, it didn't work. I think I haven't had it cool down enough. You can actually see on this flask now, we actually have the beginnings of ice being formed there. You can see I can scratch it off. It's so cold, the condensation, which was just liquid, is now ice. I can scrape it off with my finger now. Look how big this balloon's getting. That's all from those few little pellets that we had left that we put into the bottom of this bottle. And meanwhile, our balloon that we started off with just the 3 pellets of carbon dioxide, that's now getting quite a bit bigger. And in the spaces where the balloon had been sitting, on that particular spot, where it got particularly cold, the condensation on the balloon even turned to ice. I'm trying to warm this up a bit, and I can feel there's a bit of pressure. So let's see if we can get this to work again. Here's our candle. There we go, beautiful. The carbon dioxide, which is hot, which is more dense than air, so it stays in the bottom. It's actually filled this container. And so by pouring out the carbon dioxide, I was able to smother the flame, because the carbon dioxide gas came down, pushed out the oxygen from the flame, and flames cannot burn without oxygen and without fuel. And so the carbon dioxide displaced the oxygen and therefore put the fire out. This is in fact the way that carbon dioxide fire extinguishers work as well. Let's try it one more time. It's so much fun to see. There we go. And maybe one last time. Nice and close. There we go. Okay, so a few things that are fun to do with ice, dry ice. And the particular thing that I wanted you to see is this sublimation. So sublimation is the process whereby a solid turns directly into a gas when heat is added. Now, we didn't have to add heat in terms of a flame like we did when we were changing the state of the ice cubes. All we needed to do was expose the dry ice, which has a melting temperature of minus 78 degrees Celsius, to room temperature, which was in fact adding a lot of heat and a lot of energy. So I hope you enjoyed the demonstration.